Okay. So we are going to talk about limassones. That's how you say it. Limassones. They're the ones that look like lily pads. Okay. When we have a limassone, they are either going to look like A plus B cosine theta, A minus B cosine theta, A plus B sine theta, A minus B sine theta. Okay, so there's 4 different standard forms, if you will, that tells us that we have a limassone. Okay, they're also really fun to say. Also, they're way easier to graph than rose curves. Really? Okay. Now, there's a couple things up front that we need to be able to remember, but graphing them, very straightforward. Okay. Now, if we have a limassone with a cosine in it versus a limassone with a sine in it, even limassone or not, what does sine versus cosine tell us? Okay, what kind of symmetry do we have? Okay, so if we have a cosine, our limassone is going to go to the right or to the left because we have that horizontal symmetry. If we have a sine limassone, it's going to go up or down because we have that vertical symmetry. Okay, now the plus or minus, did you figure out what happens if this was a plus versus a minus? Can you be more specific? Okay. But what do you mean by direction? Because this tells us symmetry. So what do you mean by direction? Okay, so if we have the A plus or B cosine theta, we know that's going to have horizontal symmetry. Okay, but more specifically, that plus is going to tell us it's a majority on the right, or the minus a majority of it on the left. Okay, now it's not going to be all to one side of the pole. It's going to overlap a little bit with all 4 quadrants, but a majority of it is going to be on one side or the other. Okay, if we have A plus B sine theta, a majority of our limassone is going to be above the pole, versus A minus B sine theta, a majority is going to be below the pole. Okay. Now, did you ever figure out what A plus B gives us? Sides. Okay. So A plus B gives us our max R value. Okay, the biggest part of our limassone from the pole is that A plus B. Now, was there just like one shape? How many shapes are there? There are 4 different limassones. This is where it gets exciting. Okay, now first of all, let's keep in mind that A is that first number and B is the second number. It's the coefficient with the sine or cosine. Okay, if we take A divided by B, we determine what kind of type we have. So just real quick, drop your pencil and listen to me for a moment, and then you can write down what you need to. Okay, first of all, I have A plus B cosine theta graphed up here. Okay, now if we had like a negative, they'd flip. If we had sine, they'd be up and down versus left and right. Okay, so if A divided by B is less than 1, then we have a loop. So this goes through the pole and it creates a loop inside. They're really fun. If A equals B, then we create this guy. It's called a cardioid because what does it look like? kind of looks like a heart if this was a little bit more like pointed, right? It does kind of look like a bean. Okay. Cardioid, where we have like the corner at the pole. Okay. Now these two, do they go through the pole? No, they don't. If A divided by B is between 1 and 2, we have what's called a Dimple of Limasson. So it kind of like dips in a little bit. Sort of like if you had like a ball of Play-Doh and you like touched it, it would like dip in a little bit. Or like, I don't know how many of you like bake, but if you had like a big ball of like pizza dough.
Like if you were dribbling a soccer ball and touched it a little bit. It's slightly deflated.
Yeah, pretty much. And then if A over B is 2 or bigger, we have a convex Limasson. So it basically looks like our ball of Play-Doh sat on a table for a little bit and it got a little bit smushed. Write down what you need to. No, it's like a ball of Play-Doh that sat on the table for a little bit. What? A red?
A red blood cell.
Yeah. I agree. No. Well, it's not concave, so it's convex. All the other ones are concave, they dip in. Convex means it doesn't dip in at all. Do you see what I'm saying there?
So convex doesn't mean it goes out, it just means it doesn't go in.
Yes. Well, I mean, what you said is this, never mind. How are you saying that that doesn't go out?
Like it doesn't repeat. I was thinking of more so it's like a star.
I'm waiting for you to write down what you need to. You need to be able to tell me what kind of Limasson that we have. So like yesterday, when I asked you for the type, you said rose, 4 petals. Here, you're gonna say Limasson, dimpled, Limasson, loop. Now, some of you might be a little nervous about remembering which one is which. Okay, so just remember this. Lucy loves dimpled cuties. Lucy for loop, loves heart, cardioid, dimpled, cuties, convex. It's just a mnemonic device to help you remember the order in which they go. Less than 1, 1, between 1 and 2, 2 or bigger. You can change it to whatever works for you. Linus, Lewis.
Whoa.
No. Okay, are we ready to do some graphs? Patton is not, but we're gonna go. Write it down. Write it down. Okay, I would like you to have a conversation at your table. What kind of Limasson is this, and where is the majority of the Limasson going to be graphed? Ready, set, go.
Yeah. Oh,
It wasn't that bad.
All right, let's chat. Brock, what type of Limasson do we have? One with an inner loop, okay? Because we have cosine, well, let's talk about that loop. A divided by B, 2 divided by 3 is less than 1, which is why we have a loop. Okay? We have a plus and we have cosine. This is telling us, Hank, that a majority of our Limasson is going to be where? To the right. Good. Our max R value. Isaac, what would we say that is? Yeah, 5. We take 2, we take A and B and we add them together. Okay, we have done the hardest part. Can you believe that? Any Limasson that you graph, you are going to plug in 0, pi over 2, pi, 3 pi over 2, and then back to 2 pi. Every time you have a Limasson, you are going to plug in those numbers. Traumatic? Let's plug in 0, and I need you to help me. When I plug in 0, I have 2 plus 3 cosine of 0. The cosine of 0 is 1. Okay. Please silently think about what the cosine of pi over 2 is. When we have 2 plus 3 cosine of pi over 2, we get 2, because the cosine of pi over 2 is 0, so we have 2 plus 3 times 0. Think silently in your head about what the cosine of pi is. If we have 2 plus 3 cosine of pi, we get 2 plus 3 times. Okay. Ooh, so we have -1. So pi, but then let's go backwards 1. Okay. Think silently about what the cosine of 3 pi over 2 is. 2 plus 3 cosine of 3 pi over 2 would give us and then plugging in 2 pi gets us back to this coordinate right here. Okay. So remember, we do have a loop. And what did I tell you about the loop? What does it go through? The loop needs to go through the pole. If it doesn't, I'll count points off on your quiz or test. Okay. So the loop needs to go through and make it look as symmetric as you can. How many times did we go through the pole? We went through twice. Oh, this is weird. I'm done filling things out. What am I not asking you to do? I'm not asking you to find the zeros. We set that equal to 0. We have the cosine is equal to -2/3. You can't find that without a calculator. And this is a non-calculator section. So we're just not gonna worry about it. We know that there are 2 zeros, but we're not gonna find them. I'm sorry, is that okay? Are you gonna be upset? No, you don't think so? Nicolette is, okay. All right, questions about this one? Let's do another one then. As you're writing this down, I want you to think about what type of Limasson we have. Jalen, what type of Limasson do we have? Okay, we're gonna call it a cardioid. And I dislike spelling it. Okay. Nicolette, how do we know it's a cardioid?
Because it equals 1.
It, Eric, being what? A divided by B equals 1. Okay, A and B are the same. All right. Where, think about it, don't shout it. Where is a majority of our Limasson going to be? Right, left, up, or down from the pole? Nick, what do you think? Down. We have sign and we have a negative in there. It's going to be down below the pole. Okay. Our max R value, if we take A plus B, our max R value is 8. I don't have 8 concentric circles up here. So I'm going to go ahead and I'm going to count by 2 so I can fit my cardioid on here. Okay. All right, so we're going to plug in 0, pi over 2, pi, 3 pi over 2, and we'll cycle back to 2 pi. Okay, now. Yep, because technically I shouldn't call it a negative, it's a subtraction. Okay, we're either adding or subtracting. Okay, so it's just telling us where our cardioid's going to be. It's not attached to B. Okay, all right, the sign of 0, everybody, the sign of 0 is 0. So 4 minus 4 sign of 0 would give us 4. So then you have 4 minus 4 times 0. Okay. Pi over 2. The sign of pi over 2 is 1. So 4 minus 4 times 1 gives us 0. We're at the pole. Pi. 4 minus 4 sine of pi. The sine of pi is 0. So we have 4 minus 4 times 0, which gives us 4. Okay. When we plug in 3 pi over 2, the sine of 3 pi over 2 is a -1. So we have 4 minus 4 times -1. Ooh, we have 8. Is this a triangle? I have 4 points. They look like they're in a triangle. Okay. At the pole, we have to come to a corner. Everywhere else is curved. Yeah. better. Okay, how many times did we hit the pole? Once. We have 1, 0. It touches the pole. This is the only one where you're gonna have like that corner. You're gonna have a sharp edge at the pole, smooth everywhere else. Okay, every other cardioid is smooth everywhere. This one does have a corner, so I need to be able to see that. Okay. This one I think looks the most like a lily pad. Okay, should we graph 2 more? Let's do it. Does it track me? I mean, most of the day. Yeah. Second hour is just a banner presentation, and then they actually have events for a good chunk of the day. Have a conversation with your pod about what this is going to look like. Okay. All right, let's talk about this together. Owen, what type do we have? Did you say dimpled? Dimpled, like a dimple. Dimpled. Okay. Okay, 4 divided by 3 is between 1 and 2. So we have a dimpled Limasson. Mallory, where is the majority of this Limasson going to be? Okay. To the left, we have cosine and we have a subtraction in between A and B. So it's going to be to the left. And our max R value would be what, Bajik? Not quite 8. Add them together. 7. Okay, ignore the subtraction in between. We add those together. Okay, now. Okay, so we are going to plug in 0, pi over 2, pi, 3 pi over 2, 2 pi. Pod 1 and 2, plug in 0. Pod 3, plug in pi over 2. Pod 4, plug in pi. Pod 5 and 6, plug in 3 pi over 2.
We only need to do one.
All right, pods 1 and 2. What is R when theta is 0? What about pi over 2? You're supposed to. Pod 3, pi. Pod 4, 3 pi over 2. Wait, what? what's pi over 2? Oh, cool. Pod 4, what's pi? 3 pi over 2. Okay, I'm gonna count by twos again. So we have 1, 4, 7, 4, 1. Now remember this one. Like, the dimple, like on your cheek, a dimple, right? Make it look nice and smooth. Does not look like it. How many times did we go through the poll? Did we? We didn't go through the poll at all, people. Poll's right here. We don't have any zeros because we didn't go through the poll. Cool. There will never be any zeros for dimpled. What about here when we have a convex? Are we gonna have zeros on a convex one? We'll find out. Okay, so this is our last example. Yay! R equals 5 plus 2 sine theta. A divided by B is 2 or bigger. So we know, no, they're not. So this is a convex. Nice. Grayson, what did you get? All right. We have a max R value of 7. Okay, the sine of 0 is 0. So when we plug in 0, we get 5. The sine of pi over 2 is 1. So when we plug in pi over 2, we get 7. The sine of pi is 0. So here we get 5. The sine of 3 pi over 2 is -1. So here we get 3. So it just looks like a squished, roundish object. And did we go through the poll? No. Nor will we ever on any convex wing. So dimpled and convex, you're not going to go through the poll. You're not going to have any zeros. Cardioid, you're going to touch the poll once. Maybe twice, if you, unless you start at the poll and then you would touch it twice. Then a loop, you're going to have 2. Okay. All right. So we have a worksheet for our homework. Let me stop the recording.